Hi, I am Sampriti, and I am showcasing my project on synthetic data generation for NER and classification. Now, why synthetic data? Real world datasets are often limited, noisy, or pose privacy risks. With synthetic data, we can safely simulate realistic examples, generate underrepresented categories, and evaluate model performance under controlled settings. I use two tools in my project: Prompt Write for data generation from scratch, and Crawl for AI for generation through web crawling. First, I will be showing how Prompt Write works. First, we are generating the entire report, including all PII information through LLM. Here is the system prompt I have defined to instruct the LLM on the type of output I want. Some key features of this are format specifications for PII, instructing the LLM about the length of reports I want, and specifying the type of output I want. In this case, it is plain text. We pass the system prompt into the topic tree. This is the main feature of Prompt Write. It helps ensure that the topics are diverse yet semantically correct. For example, here the root prompt is medical reports, while degree is 2 and depth is 3. So we get 8 paths in total. Now all of these 8 paths, along with the system and root prompts, are fed into the data engine. The data engine considers the 2 prompts along with all the nodes in current path to generate a report. Here, we can see 7 generations were successful, while 1 failed. After some processing, this is what the reports look like. On running a script to check content similarity using Sequence Matcher, we see that no similarity is found among the reports. Now we move on to a method which allows us to distribute our workload among different LLMs. This is useful when the generation process is slow, and we want to parallelize our work for increased efficiency. The system prompt and topic tree remains the same. We use one LLM to generate the entire topic tree as usual. But what we do differently is, we take all the existing paths from our topic tree, randomly shuffle them, and feed part of them into one data engine and the remaining to another. Each data engine uses a different LLM to generate output. I have used Grok Llama and Gemini 2.0 Flash models here. And here is the output we can see: half generated by Llama and the other generated through Gemini. Next, we move on to the code I specialized for our required tasks. This is specifically for generating reports in the financial domain. These are the specific type of reports we required in this sector. What my pipeline does is that it takes each of these categories one by one, defines the system prompt according to them, and builds a different topic tree and data engine for each of them. You can see how a different topic tree was created for each of them. And this is how the reports look for different categories. A special part of the prompt here is that I specifically included what format I want the balance sheets to look like, and the LLM incorporated that into the final balance sheets generated. Next, we move on to NER documents. Here, as a step towards ensuring balance in entities, I grouped all the entities I wanted to be included in the reports by their occurrence frequency: common rare type 1 and rare type 2. I have hidden the entities for privacy purposes. I defined a different topic, tree and data engine corresponding to each group. I also defined the structure of the documents generated, where the actual document would be first and the near tags would be next. After generation, I saved the reports into output folder, which contained the text documents, and the predictions folder, which contained the ground truth, the respective NER tags. Now, lastly, for the web scraping library, Crawl4 AI, I explored two main techniques, a depth-first approach and a breadth-first approach. In both of these, we define a set of keywords we expect from extracted reports. The library uses an internal scorer to determine how similar a web page is to our list of defined keywords. If the similarity exceeds a given threshold, we go through with the web scraping and collect the output. We also need to provide a list of URLs to search for. The breadth-first approach tries to follow all hyperlinks at a particular depth, while the depth-first approach tries to cover a specified depth first, before returning back and proceeding to the next hyperlink. And this is what the raw output from this web crawling looks like. To summarize, this project demonstrates how prompt engineering, topic control, and open-source LLMs can be combined to generate high-quality, controllable, and privacy-safe synthetic datasets. These datasets can be used to augment training pipelines, test NER models under rare entity scenarios, and simulate real-world document formats at scale. Thank you for watching.